very good morning to all of you. Let us start the analysis of 2015 Bullcat 1. Yes guys, let us start. Yes, question number 2. Any problem in this question? I think this is hit and trial only. Easy question it was. Some Vedana, I'll say there is no shortcut for this question, rather I'll go by putting values. See, what is the thing given here? A is less than equal to B is less than equal to C, and A factorial plus B factorial plus C factorial is equal to 3 raised to power D. So if I take, suppose A is greater than equal to 2, suppose, I mean I'm considering that the least value is 2. If I take this, of course B is more than A and C is more than B. That's why all of them are even. And sum of 3 even numbers will be even always. So it cannot be equal to 3 raised to power something. So A has to be 1 only. These were the logics. A should be 1 only. That is the only possibility. Now, if I take B as, say, 3. 2 I am skipping for once. So C should be more than equal to 3. Now, if B is a multiple of 3 and C is a multiple of 3, the total B plus C should be a multiple of 3. And whenever you are adding 1 to a multiple of 3, you cannot get a power of 3. That's why B cannot be 3. B should be 2 or 1 always. Are you getting me some Vedana? These were the hit and trial things. So I can consider, please confirm, yes, okay, some Vedana. This is first value. Now, A is 1 I am considering. Once again, B is considering I am 1. And suppose C I am taking as they are 2. And C suppose I am taking 2. The addition will be 4, which is not a multiple of 3. But if I take this as 3, it will be 3 factorial plus 1 factorial plus 1 factorial, which will give you 8 again, which is not a power of 3. So this is not a possible case. By hit and trial only we can go further. Is it okay? Yes. Yes, still any problem in this question? Now let us move. Question number 3. Nice question. Number system. Yeah, any problem in this question now? Shashidhar, I'll come to that question. Okay, Shreya, Rashmita. Let us see what is the thing here. The difference between the product of first 200 positive even integers and the product of the first 200 positive odd integers is always divisible by what? So what is the thing asked? The thing asked is 2 into 4 into 6 into so on up to 400. That is the multiplication of first 200 even number. Then I am taking the first 200 odd number. That is the required thing. So what is asked here? We want to calculate whether S is divisible by 401 or not. 403, 399, as you can see all of these as one of the option. So I'll check it for every option. Now I'm taking easy options. Say I'm taking 403. As 403, is it a prime number? 403. Is it a prime number? No. It is 13 into 31. How can you check whether a number is a prime or not? You will take its closest square root. 403 square root, which comes out to be 20. So I'll check the divisibility of 403 by all the primes which are less than equal to 20. So it comes out to be 13 into 31. Similarly, 399, that can be written as 3 into 7 into 19. Now 401, that is a prime number. So first of all I am taking 13 and 31. Of course 13 and 31, they will be present in the multiplication of odd number, because 13 and 31 they both are odd number and less than equal to 399. Now, if we take the multiplication of all the even number from 2 to 400, can you say, of course, 26 will appear here? That is a multiple of 13. 62 will appear here. Of course, because that is an even number and that is a multiple of 13. From these two numbers, I'll take out 13 and 31. So, from the total multiplication, I can take out 13 into 31. So, the remaining thing will become 13 into 31 into something. So, definitely this number is divisible by 403. Are you getting me? Swar, Rashmita and Shreya? With the same logic, we can check it for third option. So, second and third, they both are the answers. Of course, I will not check it for first option because I am getting two answers. So, what is the answer in this case? It will be all of these. Is it okay? Yes. Now, suppose you want to check it for 401. Now, it was a tricky. Now, let 401 is equal to some y. What was the question? It was 2 into 4 into 6 into so on up to. It was 400 minus 1 into 3 into 5 into so on up to 399. Now, if I take y as 401, every term in the first expression can be written as y minus 1, y minus 3, y minus 5, so on up to y minus 399. And same is the thing here. If I solve this expression, I'll get a huge expression consisting of y's, some power of y, and there will be one term which will be the multiplication of all the odd numbers. But we have the same thing in negation, so they will be cancelled. So we'll get an expression which is a multiple of y because we can take out y. And since we were taking 401 as y, of course, this number is a multiple of 401. Is it okay? Sahil? Since 401 is not breakable, that is a prime number. That's why I have taken this approach. I'm trying to relate every number with 401. Is it okay? Okay, let us move. Question number 4. Very, very good question on Gint function. Greatest integer less than equal to x. Any problem in this question? Please write explain followed by your question number in the chat box. Sometime you are late in responding, so I cannot understand which question you are talking about. Okay, Shashidhar. Find the number of positive integers x which satisfy the condition. See, x by 99 and we are taking Gint of this function. And on the right hand side we have x divided by 101, which is again we are taking Gint here. And as you know, what is Gint? Gint is always an integer. So two integers are equal actually here. So if I consider let it be equal to 1. Suppose both are equal to 1. So how many values are satisfying here? First of all, I can take 0 as well. Suppose I am taking 0. If I take 0 here, I can take any value since the question says positive integers x. That's why I am starting from 1. I can take any number from 1 to 98. For this expression, I can take any number from 1 to 100. But I need both these conditions, so I'll take the intersection. So what will be the final value in this case? In this case, I'll take all the numbers starting from 1 and going up to 98. Is it okay with you? Suppose this value is 1. If this value is 1 for the first expression, we can start any value from 99. We can take 100 as well. We can go up to what? It can go up to 197. For the second expression, we can start from 202. We can go up to 302. Why are we stopping here at 302? Because if we take 303 by 101, it's Gint. It will come. It will be what? It will be 3 in this case. But we are considering it in this. Are you getting me, guys? I have skipped it. It will be 201. Now I'll take the intersection part. I'm starting from 101 going up to 197. Similarly for 3, it will be starting for, yes Shashida, that was my mistake. So I have inserted one line as well. So I'll start from 101 and I'm going up to 201. Are you getting me, Shashida? Now is it okay? Yes. Okay. Similarly, we can go up to the multiple of 3. Similarly, we can go up to 303, so on up to. That is the case. And we'll take the intersection part. Similarly, we can go. How many values we are getting here? 98. Here we are getting 97 and so on up to. We'll get a pattern. We can apply the formula for AP. Is it okay now? Clear? Should I move further? Okay. Let us move. Question number 5. Yes, Shashi, it's lengthy. I'll say it's not lengthy actually. By taking 3 or 4 steps, the idea will be clear. Then you can you can apply any formula to find sum of a series. Yeah. Question number 5. Any problem? No, Shashidhar, you cannot actually. You should write it for at least 4 steps, because in that case only you will know whether this is a series of consecutive numbers or odd numbers or even numbers. Okay, Shubhangi, how many ordered solutions? First of all, this is important word. What do you mean by ordered pair? Ordered solution, it means if you are getting a solution 2, 3 and you are getting a solution 3, 2, they both are different in this case. But if we talk about pairs, then 3, 2, 2, 3, they both are same. So what is the question here? How many ordered solution sets PQ, where PQ are prime and P is not equal to Q, are there such that P square plus 7PQ plus Q square is the square of an integer? So you will find many questions on integral solutions. So you can go through the video. You can make an account in hitbullseye.com. You can go through those videos. They are very helpful actually. This is a kind of integral solution question. So let us see. First of all, I'll try to make a perfect square here. What is it saying? It is saying that it should be square of an integer. So I can make a perfect square here. It can be P plus Q whole square. I'm left with 5PQ, and this is equal to M square, where M stands for any integer. Now the normal technique we always follow in integral solutions. Completing squares we call it. So I'm applying now x square minus y square formula. It will be this and this. Now you can equate them. Suppose there can be many solutions here. Suppose I'm considering this is 5 and this is PQ. I can consider this is 5P and Q. I can consider this is 5Q and P and so on. There can be numerous solutions. First of all, I'm taking the first case where I'm considering M plus P plus Q as 5P and M minus P minus Q as Q. If we subtract them, or suppose we are adding them, we'll get 2M is equal to 5P plus Q. M will be equal to 5P plus Q divided by 2. Now we want to substitute those values of P and Q for which this expression is an integer. So we can go by hit and trial. Similarly, we can discuss more cases. Let it be M plus P plus Q is equal to, suppose, 5Q. Another case, we can take it as P. Now we can solve it and you will get the values. Is it okay, all of you? You are adding here, you can take the subtraction as well. If we take the subtraction, we will get P plus Q plus P plus Q is equal to 5P minus Q. You can get the values. This is always taking, whenever you have integral, number of integral solution question, and you have square in that, that is the normal technique. You always try to make a complete square. Is it okay? Shubhangi, should I move further? Calculation part I'm leaving for you. I don't remember the answer actually. Answer is second option, that is 2. We are getting only 2 solutions. Nipun, I'm not getting you. Indrajit, if you are comfortable in quant section, I mean, if you are not comfortable in verbal, but quant section is your comfort zone, you should try these kind of questions. But if you are not comfortable, but you are pretty comfortable in AR and verbal and DI, math is your weakest point, then you can leave these kind of questions. Of course, they will take time. Pranav, normally whenever we do integral solution questions, by using hit and trial, always we skip some solutions. It's better you go by a technique only. Rashmita's, I think there is a video uploaded on I think hitbullseye.com YouTube. You can go through that video. Yes, Arpit. There is a lecture based on integral where you will find all the types of integral solution questions with some shortcuts as well. Is it okay? Should I move further now? Nipurn, I'm not able to understand you. You said third case. What is the third case here? Indrajit, it will take approximately 3 to 4 minutes of yours. I am getting 2P plus 2Q minus PQ is equal to, okay, in third case. Nipun, see what is the case here? It is saying P is not equal to Q. That's why we are rejecting this. If we consider the third case, we'll get P and Q, they both are equal. But it is saying PQ should be distinct. That's why we are not taking that case. Is it okay? That is also a condition. Okay, let us move again. Kind of similar question. You can see a square here. Should I solve this sum for you, all of you? Yes, Prajakta and Shashidhar. See the expression. This is 2p plus 1 whole square divided by 2p plus 7. Whenever you have these kind of questions, always try to make an integer either in denominator or in numerator. Now, in this plain statement, you have variable in both these things. I mean, in numerator you have a variable, in denominator you have a variable. It's better you try to eliminate variable from either denominator or numerator. Now, simply I'm writing this as 2p plus 7 whole square, or you can do one more thing. What is 2p plus 1 whole square? If you are not comfortable in counting, this is this. This will be 4p square plus 4p plus 1. 4p square plus 4p plus 1. 2p plus 7. You can multiply this by 2p. If you are not comfortable, you are a layman in maths, minus 4p plus 1. Then you can take minus 2 here. It will give you minus 14, which comes out to be this. So directly you can write this number as 2p minus 2 plus 15 divided by 2p plus 7. Is it okay? Clear? Yes or no? So let us start. I think I have made a mistake in calculation. Let us see once again what was the question. It was 2p plus 1 whole square divided by 2p plus 7. Yes, actually. Yes. So directly I can make this. I'll simply write it as 2 plus this thing because I want to make 2p plus 7. See, it will give you 4. What was that actually? It was 4p square, 4p plus 1. I'm getting a 4p square here. I'm getting a 49 here, but I need a 1 there. So I can add 48 extra. Subtract. One thing more. I need a 4p, but here I am getting what? 28. So I'll subtract that. Are you getting me? Yes or no? Yes. So Manjinder, if you are not comfortable in this thing, leave it. Okay. I think simply I'm taking a smaller example, Manjinder, for you. Suppose I'm taking this number 23. That is a normal division. Is it okay? So can I say 23 can be written as 5, 3 by 4. Is it okay, Manjinder? I am applying the same technique here. So I'm writing 2p plus 1 whole square inside. I'm dividing it by 2p plus 7. I'm multiplying this by 2p to cancel this. So it comes out to be this. Subtraction now. I am getting minus 10p plus 1. Are you getting me, Manjinder, now? Yes? Okay. So it comes out to be, yes, it will be 2p minus 5 plus 36 divided by 2p plus 7. Now I want to make this as an integer and p is a natural number. Of course, if this is an integer, of course fractions are not allowed. If fractions are not allowed, it should cancel 36 in any way. I mean 2p plus 7, that should be a factor of 36. 2p plus 7, that should be a factor of 36. So whatever be the value here, what will be the value of p? It will be something minus 7 divided by 2. Of course, if p is a natural number and we are getting on right hand side division by 2, the numerator should be a multiple of 2, I mean an even number. So it should be an odd number always. That was a catch here. So we are looking for odd factors of 36. It can be 3, it can be 1, it can be 9 as well, but p should be a natural number. If p should be a natural number, 3 is rejected, 1 is rejected, because in these both cases we are getting a negative value. Only 9 is acceptable, and that is the answer in this case. Is it okay? Nipun, p is equal to 1 is not the solution, because in that case this odd shouldn't be 1 always. Is it okay? If we go by value putting, you can take p as 1, 2, 3. Are you getting me, guys? Is it okay? Okay. Still any problem in this question? Okay. Let us move. Question number 12. Dikshant, let me complete all the difficult and medium level question, then I'll come to your question. I think 7th, a query of many students. Let me explain this. I have this question with me. Let Sm be the sum of digits of positive integer m written in base 10. You are given a number in decimal system. Let n be the smallest positive integer such that 5 Sn is equal to 2013. What is the value of S 5n plus 2013? So what is the thing given? S of n is equal to 2013. What is Sn? Basically that is sum of digit. Sum of digit of a number which is the smallest number is given as 2013. If I'm looking for a smallest number, it means I'll try to make the length as small as possible. Length means number of digits. So I'll try to make number of nines as maximum as possible. So are you getting me? That was a catch in this question. So 2013 when divided by 9, it will give you 223 digits, where 222 digits are 9 and 6 is the remainder. Why am I doing this? Because it is mentioned that n is the smallest number and sum of digit of n is 2013. So I'll try to make number of digits as small as possible. So I'm trying to make maximum number of nines, because 9 is the maximum digit we can use here. If I divide 2013 by 9, I'm getting 222, that is the quotient, and 6 is the remainder. It means since I'm looking for a number which is the smallest one, so I'm starting that number by 6. If I start this number by 6, I'll get what? N will be 699, so on up to 9. That will be a huge number containing 223 digits. Is it okay? Now what is asked? 5n plus 2013. It means 5 into 699, so on up to, plus 2013 we are looking for. Now of course I cannot calculate this, but this number is very near to this number. So it will become what? It will become 35000 minus 5 plus 2013. Are you getting me? So it will become 35000 plus 2008. Of course, if there is a number which is ending in many zeros and you are adding 2008 to that, you will get a number which will be ending in 2008. What is asked here now? Sum of digits. Now what is sum of digits? You can calculate. It will be 8 plus 2 plus 5 plus 3. Is it okay? Swar, it will be 222 9s and 16. Because if you divide 2013 by 9, you will get a remainder of 6 and a quotient of 222. Okay. Let us move now. We are left with this 12th question. Yeah, any problem in this? It is a huge lengthy question, but very easy it was. Yes, Shashidhar, within I think 4 or 5 hours it will be uploaded. But it was very easy questions for Shreya. Okay, Shreya, have you read this question? Okay, it says Parvati Patil enters a forbidden chamber at the this. She is cursed and petrified and placed on a stone S which moves 25 steps per year. Now there are two stones A and B. They also move, but the movement of block S does not obstruct the movement of blocks A or B. A moves 5 steps towards B in a year and 4.5 steps in the direction away from B in the next year. It means what? It means in 2 years, I'm talking about the stone A. In the span of 2 years, 5 steps towards B and 4.5 steps in the direction away from B. It means it will move effectively 0.5 steps towards B in the span of 2 years. Is it okay? Are you getting me, Shreya? Now further, B moves 9 steps in the direction away from A in a year and 11 steps forward A in the next year. Now talking about B. In the span of 2 years, you can see 9 away and 11 towards. It means effectively it is moving 2 steps towards A. Now clubbing both these things. In a span of 2 years, A is moving 0.5 steps towards B and B is moving 2 steps towards A. So if I club those two statements, I can say in the span of 2 years, both these stones are moving completely 2.5 steps towards. They are coming from the opposite direction and they are trying to meet. Now what is the question? However, when A moves towards B, B moves away from A and vice versa. The initial distance between A and B is 1000 steps. Parvati's curse will be lifted when blocks A and B bang each other. It means A and B, they are meeting. In 2 years, they are coming towards 2.5 steps and the initial distance is 1000. So how many years they'll take to bang each other? They'll take 1000 divided by 2.5. Parvati, Shreya, are you getting me? Yes? Is it okay? So it comes out to be 800 years. Yes, now coming to S block, Indrajit, what is the question now? What is the sum of the distances travelled by Parvati's block, block K and block B when the curse is lifted? Now we'll take the total. Is it okay? We'll take the total for 800 years. Because after 800 years, they are banging each other. Now, once again, coming to A, in the span of 2 years, it is moving 9.5 steps. B, in a span of 2 years, it is moving kitna? It will be 20 steps. 9 plus 11. Again, going to S, in a span of 2 years, it will move 50 steps per year. Now the years total are 800. It means if we take 2 year span, we'll get 400 spans. So what will be the answer in this case? It will be 400 into 50 plus 9.5 plus 20. That is the answer in this case. Yeah, still any problem in this? Is it okay? Clear? Akshavata? Yes, since I'm taking 400 will be the 2 year span. How many 2 year span can we make from 800 years? Is it okay? Okay, I think it's not a good day for me. Please do cooperate. Yes, you are correct, all of you. I think the idea is clear. Please manage the calculation part. Yes, Rohin. Yes, of course, absolutely. Okay, let us move further. 11th question, any problem? Shubham, I'll come to your doubt. Please write explain followed by question number. It was a nice question based on a property. Or you can make cases as well. Okay, Rashmita and Shashidhar. Before explaining this question, let us do a concept which is useful in this question. Find number of non-negative integral solutions to this equation. x1 plus x2 plus so on up to xk, let it be n. What is the answer to this question? This is n plus k minus 1, ck minus 1. Avi, just a second. That is the answer in this case. Very good property. Again, you can find a video in your account on this property only. The name of this session is, I think, Permutation and Combination Advanced. Okay, let us see. Now we'll make use of this property in the question. It says a person visits a fun fair and plays a game where he has to shoot at a dial. The dial consists of 6 concentric circles. He shoots 10 bullets such that each region contain at least 1 bullet. In how many ways could his bullet be scattered across the regions? Okay, first of all, Avi, Region, this is giving you region's definition. What is region's definition here? It can be innermost circle as well. It can be annulus part as well. I mean, we are considering this as a region. We are considering this also as a region. So in total, how many regions are here? In total, there are 6 regions. Is it okay, Avi? Now, we have 10 bullets and we want that each region contain at least 1 bullet. First of all, you complete the basic condition. Give a bullet to every region. I mean, 6 bullets are out. Place a bullet in every region. I mean, 1 bullet is occupied here, 1 bullet is occupied in the second region, in the third region, 4th, 5th and 6th. It means 6 bullets are out. They are all already occupied. In total, we had 10 bullets. So we are left with 4 remaining bullets. Now, these 4 bullets can go anywhere. So, what is the question now? Question says, suppose first region is getting x1 bullet, second region is getting x2 bullet, so on up to 6th region is getting x6 bullet, and the total should be 4 always. So what is the answer in this case? It will be 4 plus 6 minus 1, C6 minus 1. The same property. I don't remember the answers actually. It is 126, Indrajit. Shashidhar, I'm not getting you. I'm considering that the first region is getting x1 bullet, x1 extra bullet, because 1 already I have given, and x2 is getting, second region is getting x2 bullet, third region is getting x3 extra bullet, and so on up to 6th region is getting x6 bullets, and the total should be 4 always. Is it okay now, Shashidhar? How 4? Okay. See, there were 10 bullets in total, and there was a basic condition that each region contains at least 1 bullet. If each region contains at least 1 bullet, first of all, I'm completing this condition. That is the essential condition. I'm trying to complete this condition. I am giving 1 bullet in advance to every region. So, 6 bullets are already distributed, 1 to each region. So, we are left with 4 bullets. That's why I'm taking this as 4. Is it okay, Shashidhar? Rashmita, actually, if you are comfortable in this property, I think you can manage any kind of question. See, what is the basic thing here? This is non-negative integral solution. Let me take in another way. Suppose I have 10 similar toffees. And I want to distribute those toffees among 4 children. In how many ways can I do this? Say first children is getting x1, second children is getting x2, third is getting x3, fourth is getting x4. The total should be 10 here. Because there is no condition, that's why I can consider every xi should be greater than or equal to 0. What is the answer in this case? It will be 10 plus 4 minus 1, C4 minus 1. Now coming to your case, Rashmita, suppose we have positive integral solutions here. It means you can start from 1. Now coming to this question, you can relate, you can find a correspondence between these two questions. Suppose the condition is every child is getting, yes Rohin, yes. Whenever 0 is also allowed, then this formula is applicable. Suppose 0 is not allowed. At least 1 toffee every child is getting. Now, if every child is getting at least 1 toffee, I don't think you should remember one more formula. You just go by logic. You give 1 toffee to each child. It means 4 toffees are out. Your basic condition is completed now. 4 toffees you have given, 1 to each. Your essential mandatory condition is fulfilled now. Now you are left with 6 toffees. You are left with 6 toffees. Now you can distribute these 6 toffees among these 4 children without any condition. And that can be done in 6 plus 4 minus 1, C4 minus 1 ways. Is it okay? Yes, Dikshant. Yes, of course. For whole numbers, it will be n plus k minus 1, ck minus 1. But if it says natural number, answer will be changed. Is it okay? You can go by logic only. Otherwise, for natural number or positive numbers, formula becomes n minus 1 ck minus 1. That is the formula. But you can go by logic as well. Okay, let us move now. Yeah, question number 14. Any problem? It was tricky. Okay, it says 4 persons A, B, C, D are to be seated around a 6-point star-shaped table. We are considering that all these places, we are considering them as different. That's why this is not a circular permutation question. So I'm naming them. Suppose first seed, second seed, third seed. In a circle, you cannot differentiate between first and second seed. You can start from anywhere. But in this question, we are differentiating them. It is saying that this is a star and there are 12 seats. 4 persons are to be seated. And there is a condition A and B are always adjacent. And C and D are always adjacent. But B and D are never adjacent. The chairs are placed at all the 12 corners, position the 12 vertices. Distance between any 2 adjacent chairs is constant. In how many ways can 4 be seated? So what is the thing here? First of all, I'm considering that A, B, C, D, they are sitting in a row only. I mean consecutively only. So how many arrangements are possible? They can sit in this way, A, B, C, D. There is one more condition, B and D, they should never be together. So I cannot take A, B, D, C, because in that case B and D will be together. Now I'm taking BA, CD. I can take BADC as well. Now they can be this way as well. These are the only possibilities in this case. If we are considering that all the 4 persons are consecutive. Now you can start from any one of these seats out of 12 available. So in how many ways can they be seated? They can be seated in 12 into 6 ways. 12 corresponding to chair number and 6 is corresponding to the cases I have written. So in how many ways can they be seated? 72 ways. But that is not the only possibility. There can be one more case. Since AB are sitting together, AB are sitting together, CD are sitting together, but there can be a case where AB, CD, they are not consecutive. It means, first of all, I am considering that A and B, they are sitting on the star. It means you have to select one chair for A. That can be done in 12C1 ways. Suppose I have taken this chair. A is sitting here. If A is sitting here, A can sit in 12C1 ways. Now B can sit in 2 ways. Why so? Because B can be on left of A or B can be on right of A. Corresponding to B's position, I am multiplying 2. Suppose B I am taking here. Now for C and D, because we are considering that A, B, C, D, they are not consecutive. Since I am considering that A, B, C, D, they are not consecutive, so these 2 places are barred for C and D. So how many places we are left with? We are left with how many places? We are left with these many places. I cannot make use of 2, 3, 4 and 5. C can sit on first place, C can sit on 12th place, 11th place, 10th place, 9th place. Akshawata, it will not be 9. It will not be 8 as well. I'll consider this as 7. Or you can count cases. For suppose we are considering this 112. This thing. It can be 112. It can be 12, 11, 2, 11, 10, 3, 4, 5, 6 and 7. I cannot make use of this line because if I take this line, 5 will also be used, which is not so in this case. 5 is a barred place. That's why we are left with 7 ways. Is it okay? Into 2, why into 2? Because B and D, C and D, they can interchange their places. So either first case or the second case. That will be the answer in this case. Arpit, obviously, Arpit, I think the question you had in your paper, this was mentioned that all the chairs are marked. Akshawata, because you cannot use this line 1, 2. This is not the exact question you are seeing on the screen. Actually, this was not the question. The original statement was 4 persons A, B, C, D are to be seated this and this. The chairs are placed at all the 12 corners position and all the positions are marked by 1, 2, 3 so on up to. Is it okay? Akshawata, you got that? Sneha, what is the problem in this question? You just tell me the case you are not getting. Shubham, why 12 into 6? First of all, I am considering that A, B, C, D, they all are consecutively sitting. They are consecutive. So, I am taking all the possible consecutive cases because there are 3 conditions. A and B, they are sitting together. C and D, they are sitting together. But B and D, they are never together. That's why these 6 possibilities are here. Now, I am taking A. I am making him sit at one place out of 12 places available. How can you choose one place out of 12 available? It can be done in 12C one ways. That's why I have taken a 12 here. And corresponding to that, we have these 6 possibilities. That's why we are taking it as 72. Yes, Neha, I have taken that. B and C here are together. B and C here are together. We have so many cases. The only conditions are A and B are always adjacent, C and D are always adjacent, but B and D, they should never be together. Okay, why 7 into 2? Are you comfortable in 12C 1 into 2? Once again, I'm taking this. See, first of all, in the original statement, all the chair numbers were marked. So I'm taking this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. That is the case. It means all the seats are different. It means this is not a case of circular permutation. Okay, now why 7? First of all, I am making A and B's position. Let it be A and let it be B. So I have taken 4th and 5th position. And the second case is, we are considering that A, B, C, D, they are not consecutive. If A, B, C, D are not consecutive, A, B, C, D are not consecutive, it means I cannot make use of this position and this position. Third, I cannot use. 6, I cannot use. Is it okay, Sneha? So the remaining 2 people, I mean C, D, they can sit on this line. on this line, this line, this line. Now you can count these lines. I cannot take 7 6 lines because in that case 6 will be used. But we are considering that A, B, C, D, they are never consecutive. No, actually not. That's why I am not taking these 3rd and 6th places. Is it okay, Akshay and Sneha? So I'm putting a 7 here because I'm getting 7 lines. 1, 2, 3, 4, 5, 6, 7. 7 lines. I can choose one out of them. It can be done in 7C1 ways. Why multiplication by 2? Because CD can exchange their places. It can be CD, it can be DC as well. No, Sneha, actually not. Please read the question thoroughly. C and D are always adjacent. They should always be together. I think you are confusing the statement. Is it okay? C and D, they are always adjacent. Sneha, C could be at 3rd and 6th. That I have counted in the first case, in 72 cases. Is it okay? Rashmita, actually it is a mistake prone question. And see the 4th option, none of these. That was a main problem in this question. You just calculate the answer. Still you are not sure of your answer because of the 4th option. No, this is not so, Indrajit. Actually, in the original statement, adjacent, definition of adjacent was also mentioned. They cannot be on 3rd and 5th. They can be 3rd and 4th. It can be 4th and 5th as well. Shubham, I'm coming to your question. Okay, let us move now. 15th I have skipped. Many students have solved it. I don't know why. Okay, Vertika, question number 17th, easy. After this question, Indrajit, Shubham, I'll explain this your question. Okay, 17. A truck is carrying a pile of cubical cartons of side 1 unit. The height of the cuboidal pile is 10 units, its length is 10 units and its breadth is 12 units. There are cubical cartons of side 1 unit. One pile has a length of 10 units and the breadth of 12 units. It means in a pile, you have 10 into 12, 120 cartons. Is it okay? We have 10 piles, so there are 1200 cartons. So what is the thing given? The truck meets with an accident and 90% boxes from the top layer of the pile, which was containing 120 cartons, 90% boxes, they fall down. It means out of 120, 90% they fall down. From the second pile, it was 80%. From the next pile, it was 70%, and so on. So we can go up to how much? It will be 10%. So I can say it will be 120 divided by 100. It will be 90, 80, 70, so on up to 10. These many cartons fall down. Is it okay? Which comes out to be 540. It means out of 1200, 540 cartons, they fall down. Is it okay? Vertika? Clear? Are you getting me? Okay. Now, what is the question? Find the probability of the box being dirty. The boxes falling down get dirty. The driver repiles all the boxes. On reaching the destination, a box is picked up at random. So what is probability definition? This is number of favorable cases divided by number of total cases. You are choosing 1 out of 1200 boxes. It can be done in 1200 C1 ways. Now, what is the number of favorable cases? What is a favorable case here? Box being dirty. It can be done in 540 C1 ways. That is the answer in this case. Is it okay, all of you? Yes. Yes. Now Shubham, your doubt, you said question number 15. Question number 15 was, okay, there are 2 rows, one behind the other, of 5 chairs each, and 5 couples are to be seated. Okay, Shubham, are you comfortable in derangement? Have you heard of this? Derangement of n things. What is the formula? Derangement of n thing is in factorial. It will be 1 by 2 factorial minus 1 by 3 factorial, so on up to 1 by plus minus whatever 1 by n factorial. I'm not going into derivation, I'm just telling you the formula. Suppose we have 3 boxes, one is red, one is green, and one is yellow. We have 3 balls as well, one is red, one is green, and one is yellow. We want to put these balls into these boxes such that one ball is going to one box only. So in how many ways can this be done? 3 factorial. But what is the case if it says that red ball is not going to red box, green ball is not going to green box, yellow ball is not going to yellow box? This is called derangement. What is the derangement of 3 things? Now we are saying red is not going to red box. So if these are the boxes, either in red we can put a green ball or a yellow ball. If in red we are putting a green ball, we are left with red and yellow. So this will be the possibility. If we are putting yellow in red, we are left with red and green. So this will be the possibility. So we will say that derangement of 3 things can be done in 2 ways. Question becomes easy if there is a smaller number, but if we have bigger number, say 4, derangement of 4 things. You will make cases, but we have a formula. What is that formula? This. Derangement of n things can be done in these many ways. D4 is 9. It's better if you know these values. D5 is 44. Now coming to your doubt, Shubham. Question was, there are 2 rows, each containing 5 chairs. There are 5 husbands and their respective wives. You want to make them sit such that no husband sits in front of or behind his wife. Now, we can do one thing. We can, out of these 10 chairs available, we can select any 5 out of that. Say those 5 chairs are 1, 2, 3, 4 and 5. That can be done in how many ways? 10C 5. Is it okay? Are you getting me? Shubham, please confirm. Now, they can be seated into 5 factorial ways. Now, every husband is not sitting in front of or behind his wife. So that is a question of derangement only, that can be done in 44 ways. That is the answer. Is it okay? Let us move. Okay, question number 19. Avi, is it okay? You have understood the derangement formula? Okay. So question number 19, any problem? Please make it fast. We are short of time. Pranav, do you have any problem? Please write explain. I don't get always. Yes or no, I don't understand the meaning. Please, okay. N is the least positive integer. That is 11 times the sum of its digit. Let it be a 2-digit number. Let it be AB. What is the condition? That is 11 times. The number itself is 11 times the sum of its digits. So we can say a plus 10b is equal to 0. It will be nothing but the number which is never possible. A 2-digit number can never be equal to 0. So we can consider a 3-digit number. So what is the case? It will be 100a plus 10b plus c is equal to 11 times A plus B plus C. So what is the case becomes? It will be 89A is equal to B plus 10C. Since we were looking for least such number, so we can now go by hit and trial. You can see 89 here. A I can take as 1. Now it becomes 89. So C can take the maximum value as 8 and B as 9. So what is the answer in this case? It will be 198. I cannot take 2 here because in that case, see, ABC are digit. The maximum value of ABC we can use is 9. That's why 2 will not satisfy it. And we were looking for a least number only. So we have got our number. This is 198. Is it okay? Okay, let us move. 32nd. Nice question. Kind of last year question. Any problem in this? 32nd. Shashidhar Rashmita. Okay. ABC play a card game. The starting amount of money each has is such that 12 times the amount of money A has is equal to 15 times the money or amount of money B has and 20 times the amount of money C has. Okay. So let the initial money A is having is A, B is having is B and C is having is C. So what is the first condition? This is 12A is equal to 15B is equal to 20C. So by solving it, we can get the ratio. I think you must be comfortable in this. In finding ratios, we are getting 5:4:3. The money they starting with. By the time they are finished, the amount of money left with them is such that 6 times the amount of money. There is one more condition. I'm solving it directly. This is 4:3:2. Prajakta, Rashmita and Shashidhar. Are you able to understand this? Are you able to solve it? The ratio part? Okay. So, the winner among them has 1 rupees 36. Find how much money he, winner, had in the beginning. Now, first of all, we will find who is the winner. C, A, B, C. Initially, what is the total here? It is 12. What is the total here? It is 9. They are distributing their money between themselves. So, the total money in both these cases should be same always. So, I can take a multiple of 12 and 9. I can take 36. Are you getting me? The total money should always be same in both these cases because they are dividing money among themselves only. So, if I multiply to make it 36, I am multiplying this by 3 and this by 3. So, what was the original money of A? It was 15. For B, it was 12. I am multiplying the whole ratio by 3 because multiplication or division in ratios, it will not change the ratio. The initial money with C is 9. Now, multiplying the second ratio with 3. So, A is having 12 rupees. B is having 9 rupees and C is having 6 rupees. It means A is the loser, B is the winner. Now what was the question? Find how much money he had in the beginning. Now you can apply the unitary method and you can go on. Is it okay? Once again, I have made a mistake. Not a good day for me actually. It should be 16. I'm so sorry. It should be 16, 12 and 8. Loser, same money and the winner. If A is the winner, there is a total of 1. That one is equal to 36. Now you can apply the unitary method. Is it okay? Yes, Rashmita and Prajakta. Nipurna, Arpit. Yes, of course. Okay, let us move further. 33rd. Easy, I think. There are many numbers which leave a remainder 1. It's a question of least common multiple only. Any problem in this? Yes, yes, it was easy. Okay, let's move further. "31st swar." Okay, first of all, do you have any problem in question number 34? It was very easy. Okay, Shashi. The alphabets of the word education are arranged to form all the possible words taken all at 9 at a time. Find the probability that a randomly chosen word would have all the vowels appearing in the alphabetical order. If we go by logic, what is the answer? It will be this 1 upon 120. In the word education, how many vowels are here? They are 5. Important word because this word contains all the vowel. So you can see many questions based on this word. So the word is education. See the vowels here. It is E, U, A, I, O. Suppose D, C, T, N, that is always fixed. Say that is always fixed. So whenever we are counting the number of arrangements, we can rotate them in how many ways? 5 factorial ways. But I need what? I need a favorable case. What is that favorable case? The vowels appearing in the alphabetical order. So it means what is a permissible way? This A, E, I, O, U. So what will be the answer in this case? It will be 1 by 120. Clear? That is by logic. Is it okay with you, Shashi? Now coming to complete application of this permutation and combination. What will be the total thing here? It will be 9 factorial. I'm using probabilities definition. In the denominator, I have written 9 factorial because education that can be arranged in 9 factorial ways. Now, we want D, A, E, U, A, I, O. They come in alphabetical order. First of all, I'm selecting 5 places out of 9 available. Say those 5 places are first. Say those 5 places are first, 4th, 5th, 7th and 9th. They can be any 5 out of 9. At the very first place I'm putting A. At the second place I have chosen I'm putting E, then I, then O, then U. It means there is only one possibility. Remaining 4 things, they can be commuted in 4 factorial ways. Now you can solve it, you will get the same answer, which comes out to be 1 upon 120. You could go by logic, you could go by the complete application as well. Is it okay? Clear? Okay. Now, question number 31st, somebody asked. I think this is an easy question. Who asked 31st? I think Swar. Yes. Okay. Let us see. Number given is x raised to power 17 minus x minus 4 raised to power 17 plus x raised to power 19 minus plus x. What is the remainder when n is divided by 19? So we want to check the remainder by 19. First, x is the largest 2-digit prime number. What is the largest 2-digit prime number? That is 97. So we know the value of x. So of course we are able to calculate the remainder. See, we are not interested in remainder. We want to check whether we can find the remainder or not. So no need to calculate. Simply since we know x value, obviously we are able to calculate the answer. Is it okay, Swar? So by using first option alone, first statement alone, we can answer this question. Now going to B. It says x is a natural number. X is a natural number. It means x can be 1, 2, 3, 4, so on up to. So for various values of x, we'll get various remainders. That's why by using second statement alone, we are not able to answer this question. That's why what is the answer? You can see the directions. You can mark the answer. So I'm not getting you actually. What was the problem in this question? Okay. Okay. 33rd, Shubham. There are many numbers which leave a remainder of 1 when divided by each of 2, 3, 5. So if you are comfortable in application of least common multiple, I'm taking the very first condition first of all. There are many numbers which leave a remainder of 1 when divided by each of 2, 3, 5. So what is the least common multiple of 2, 3, 5? It will be what? 2, 3, 5. Make it fast please. 30. So my number will be of the form 30k plus 1. Now what is the next condition? But are completely divisible by 11. It means I want a number which is of the format 30k plus 1 and this is divisible by 11. Now you can go by hit and trial, and if you are not if you are comfortable in solving algebra question, you can go by equation as well. Now you can write it as 2k plus 8k plus 1 divided by 11. Now we want a number k for which 8k plus 1 is divisible by 11. That is one way. Or directly you could write, Shubham, are you getting me? We are looking for 30k plus 1 types. So I'm writing down all the numbers. They are 1, 31, 61, 91, 121 and so on up to. We want a number which is divisible by 11. So I'm checking the divisibility by 11. It is leaving a remainder of 1. It is leaving a remainder of 9. Are you getting me? Yes? Shubham? Are you getting me? So, by finding it, simply you can see 121. That is giving a remainder of 0. When divided by 11. It means 121, that is the least possible number, least possible positive number. We want third such number. So, first of all, I'm clubbing these things. The numbers which are satisfying both these conditions. It will be this way. That will be the answer in this case. Now, taking the least common multiple of this, it will be 330. K plus 121. K, 0 will give you the least value, 1 will give you the second least value, 2 will give you such third number. So that is the answer in this case, which comes out to be 781. Is it okay, Shubham? Shubham, 61 is not divisible by 11. Rather, 121 is divisible by 11. We are looking for the remainder 0. Is it okay? See, we were writing 30k plus 1 types number. Is it okay? Okay, let us move now. Now question number 39. Easy, I think. But many of the students have not attempted this set. I think you always exhaust your energy in first 30 questions. You should scan the paper first of all, because 39 and 40, they were attemptable questions. Any problem in these two questions? 39 and 40th? Yes, all of you, I'm waiting for your response. Yes, Pranav. Shashi, yes. It says Amar and Sameer played a card game where cards from ace to up to 8 of all 4 suits are shuffled. It means there are 4 suits and we are using cards from 1 to 8. These cards are kept with face down. Value of each card is same as the number of the card. Then each player takes out one card from one's own respective card. The player with the card of higher face value. Here comes the logic. The player with the card of higher face value is the winner. The loser pays the winner the amount equal to the difference between the full value of the 2 cards, in case they are of same suit. But if the cards are of different suits, then the loser has to pay twice the difference between the face value of the 2 cards. If the cards have same face value, then nobody pays and moves to next card. Initially, both Amar and Sameer has 100 rupees each, and in one round all the 8 cards are shown. That is the complete one round, showing all the 8 cards. Now, what is the maximum amount that Sameer can have at the end of one round? That is the question. So we are looking for maximum amount. Of course, we will go with this line, but if the cards are of different suits, then the loser has to pay twice the difference between the face value. The maximum card one can have is 8. The minimum card one can have is 1. Suppose they are showing their cards. They are showing their all the cards. Suppose we can have maximum 4 number 8 cards, because there are 4 suits. There will be an 8 of spade, an 8 of club, an 8 of diamond, and 8 of heart. Similarly, 1 of 4 suits. Maximum we can have 4 cards of each number. So what is the difference here? Since we are looking for the maximum amount, we will consider when they are showing their card. When Samir is showing his card, he is getting an 8, and when in return Amar is showing his card, he is showing a 1 of different suit. So Samir will get twice of 8 minus 1 in one go, and we are considering this for 4 times. So the 4 cards are over. Now coming to remaining 4. The numbers we can consider 7 and 2, because the difference now maximum is 5. Similarly, we can take 2 and 4. Yes, Pranav. Absolutely. Yeah, Nipurn, you got that? Shashi? Is it okay? The next card, the next question is similar. It's moving fast. Question number 40 is almost similar. Here we are looking for minimum amount. Now we can go for this line. If the cards have same face value, then nobody pays and moves to next card. So what is the answer in this case? 0. Because we can consider that both are showing the same card. Is it okay? Clear? Yes, all of you? Okay, let us move further. Yeah, question number 43rd, 44th. Calculation. Yeah, any problem in 43rd? It was all calculation. Pranav, which question you are talking about? This or 45th? I have data for 43rd question only, so I'm going to explain this question only. It says, if UU and EU decide to proceed for higher studies, that is the total thing given. It says, if UU and EU decides to proceed for higher studies, then what is the approximate change in percentage of pass out proceeding for higher studies? Okay. First of all, pass outs proceeding for higher studies. This thing. They are how many? They are 35890. What is the total percentage here? That is 37%. What is the approximate change in percentage of pass out proceeding for higher studies? If UU and EU, they both decides to proceed for higher studies. What is the meaning of UU? Unemployed, unemployed, neither placed nor employed. And EU means employed, unemployed. We have data for EU, but we don't have data for UU, but we can calculate that. Now, if we calculate EU, what is EU here? EU is 15,670. UU will be the 4th category. That will be the remaining thing, which comes out to be by taking the total of 3 categories and taking the subtraction from the total. We will get 34530. If they both decide that they will proceed for higher studies, the total of these 2 categories will become 50200. They are also coming to this category. So what will be the total percentage now? Is it okay? Now I think this is clear. That was the total calculation part. Okay. Now coming to 45th, good set, logical to mistake prone. Any problem in this? Shashi, refer to the data below the answer the question that, okay, in which direction are most houses facing? We want to take the direction here. First of all, I'm counting north once. I'm using red color for north. 1, 2, 3, because that is the north position. 4, I'm taking these circles. 5, 6, 7. So 7 houses are facing north. Similarly, we'll count it for east. For east, I'm using blue color. Here is the east. So for east, they are 1, 2, 3. Are you getting me, Shashi? This is 4th. This is 5th, and so on. That was the thing in this question. Is it okay? That was a calculation thing only, but very minor calculation. Mistake prone question. Okay. Now let us move. Question number 73 to 75. Avoidable set. Difficult. So many cases. Any problem? Okay, very good. These were the questions. Okay guys, that's it for today. Should I go? Okay guys, that's it. Thank you so much.